This video has the solutions to the Algebra 2 mixed review questions, starting with question 5, where we have 5 over 2 minus I. When you have a situation like this, the denominator is a complex expression. 2 minus I is a complex expression since it includes the imaginary unit I. When you have a case where you're dividing and have a complex expression, we're going to multiply both the numerator and the denominator by the complex conjugate of the denominator. So what that means, once again, the phrase that I'm talking about here is complex conjugate. The denominator is 2 minus I. The complex conjugate of that would be 2 plus I. And I will also multiply the numerator by that same complex conjugate. In the numerator, we're going to take 5 and multiply by 2 plus I. In the denominator, we have 2 minus I times 2 plus I. And let's take care of the numerator first. 5 is distributed to 2 to get a 10, and also to positive I to get plus 5i. In the denominator, we have a binomial times a binomial, so we're going to use the double distribute approach or the FOIL approach. First, outer, inner, last. First, we do 2 times 2, which is 4. Outer, we're going to do 2 times positive I, which is going to be plus 2i. Inner is going to be a negative I times a 2, which is minus 2i. And last, we have a negative I times a positive I, which would be negative I squared. We're going to bring down the numerator as is. In the denominator, we can cancel the 2i with the minus 2i. The 4 comes down, and then we have minus I squared. The other thing to realize is that we have to remember all about our powers of I. We have to remember how I to the 0th power is equal to 1. Anything raised to the 0th power equals 1. I to the 1st power would, of course, just be I. I squared, we have to remember that that's equal to a negative 1. And how an I cubed is equal to a negative I. Those are your basic powers of I that we have to remember. So we're going to trade out this I squared for what it's equivalent to. We know I squared is equivalent to negative 1. Numerator comes down as is, over 4 minus an I squared. Instead of putting I squared, I'm going to trade that I squared out for negative 1. Bring down the numerator as is. 4 minus a negative 1 is the same as 4 plus 1. So that's going to come out to be 10 plus 5i over 5. We could divide 10 by 5 to get the 2. Bring down the plus sign. 5i divided by 5 would be I. Your final answer is 2 plus I. Next question was number 7. What is the amplitude of the graph of the equation y equals 2 times the sine of 1/2 x? So here's the equation. Y is equal to 2 times the sine of 1/2 x. Important to realize the basic setup of a sine equation, where you have y equals a times the sine of bx. A is the amplitude, which is the maximum height of the function. Remember how there's a formula that we could use to figure out the amplitude, especially if you're given the max value and the min value, you're going to use that formula to find the amplitude. And x is your input, of course, and y is your output, but the b would be the frequency of the sine function. So this question was asking about what was the amplitude. It must be that a value. And just be careful to always make sure to take the absolute value of that value. In this case, the absolute value of 2 would stay at 2. But absolute value needs to be taken of that value so that we can always have a positive number as the height or the amplitude. Although it's not mentioned in this question, b is the frequency, but if you're asked to find the period of the function, the formula, as a reminder, is 2 pi over b. you take 2 pi and you divide by that frequency value, in case that would be asked. That's how you find the period. That's the formula for that. The next question that you had to do in this set was number 8. Number 8 says, if f of x is equal to 2 times the cosine squared of x, and f of x is another way of saying the output y. It's function notation for it. So they tell you the function is 2 times the cosine squared of x. They would like to find the function value when the x value is pi over 6. As a reminder, pi over 6 is the radians. It's a measurement of an angle in radians. And we could figure out how that is in degrees by realizing how pi is 180 degrees, and we're taking that and dividing that by 6. So this is the same as a 30-degree measurement. Pi over 6 is the equivalent radian form of 30 degrees. So we would like to substitute pi over 6 radians into this equation. So we know that this is going to be equal to 2 times the cosine squared of x. Our x value is pi over 6. And this is the same as taking 2 and multiplying it by the cosine of pi over 6, and then squaring that cosine value. You're not squaring the 2 though, that's important to realize. The cosine squared part only belongs here. So we're going to take the cosine of pi over 6, that value, square that value, and then multiply by 2. The cosine of pi over 6, this is one of our special angles. And let's remember our chart for these special angles. For these special angle measurements, we aren't going to use our calculator because it won't help us to give an exact answer. But we have to remember how we have the sine of theta, the cosine of theta, and the tangent of theta. And let's remember the values of those at 30 degrees, 45 degrees, and 60 degrees. The sine of 30 is exactly 1/2. The cosine is the square root of 3 over 2. And the tangent of 30 would be the square root of 3 over 3. The sine of 45 degrees is the square root of 2 over 2. The cosine of 45 degrees is the same exact value. And if we divide those, we get the tangent and get a 1. The sine of 60, okay, so the sine of 30 is 1/2, and the cosine of 30 is the square root of 3 over 2. It's going to reverse here. The sine of 60 is going to be the square root of 3 over 2, and the cosine of 60 is going to match the 1/2 value, which was the sine of 30 degrees. And your tangent value for 60 degrees is the square root of 3. So in our formula, we're asked to find the cosine of pi over 6, which is 30 degrees. So we're going to be looking at the cosine value of 30 degrees, which is the square root of 3 over 2. I'm going to trade the cosine of pi over 6 out for the square root of 3 over 2. Important to realize how we're going to square that value because the cosine was squared. And then we're going to multiply after doing that by 2 in front, the coefficient. So the square root of 3 squared would just be a 3. And the denominator also has to be squared, so 2 squared would be 4. So this is going to be 2 times 3/4. 2 over 1 times 3/4, which is 6/4. We could reduce that to be 3/2. That's the value. You might want to put 1.5, that's okay too. Or 1.5 as a mixed number, but you should be getting that ratio.